Think math.
Take 1 minus 1 plus 1 minus 1, carried on forever. Bracket it in pairs from the front, and every bracket vanishes, so the answer is 0. Leave the first one alone and bracket the rest in pairs, and the answer is 1. Call the whole thing s, and s equals 1 minus s, which gives a half. 3 answers from one expression. What exactly went wrong? With finitely many terms, this never happens. 10 numbers or 100, you may bracket them any way you like, and the answer is the same. The associative law guarantees it. But that law assumes there is a sum in the first place. With infinitely many terms, that assumption is the thing you must check first. Using the rules before knowing there is a value, that was the mistake. So go back to the definition. The value of an infinite series is the value its partial sums close in on. Here, the partial sums swing between 1 and 0. There is nothing they close in on, so this series has no value. That means 0, 1.5 are all wrong. We treated a value that does not exist as if it did, and out came any answer at all. A series that does have a value is safe. Look at a half plus a quarter plus an eighth. The partial sums are a half, 3/4, 7/8, closing in on 1. Once there is a value to close in on, any way of bracketing gives that same one. Does it have a value or not? That is the first question, always. And the tool for answering it is always the partial sums. And there can never be two destinations. Suppose the partial sums closed in on 1 and also on 2. Far along, they would have to sit near 1 and near 2 at the same time. And a single number cannot be in two places at once. So a convergent series always has exactly one value. That is precisely what we mean by saying the result is determined. To sum up, with infinite sums, existence comes before the rules of calculation. If the partial sums close in, there is a value, and it is a single one. If they do not, there is no value, and no calculation on it means anything. The 3 answers did not come from a strange expression. They came from using a value that was not there. Next time, we meet a series whose terms shrink and yet has no value at all. A sip of math, every day, here at Think Math.